We're solving problem 21 from the 2020 F equals MA exam A. A circular table has radius r and n is greater than two equally spaced legs of length h attached to its perimeter. Suppose the table has a uniform mass density with total mass m and neglect the mass of the legs. Assuming the table does not slip, we want to find the minimum horizontal force needed to tip over the table. So consider the best way to tip over a table like this is to tip it over between two legs. So if you have a line like where you tip it over at this point between, say, these two legs. Now there are not 5 legs, but just say there are 2 legs. Each length of these is radius r, and this smaller angle is angle theta, and the distance between this line and the center is d. We know that d can be rewritten as r cosine theta, or r cosine of this angle, which is only determined by how much sides there are. So this would be 2 pi over 2n, where n is the number of sides. Now at this point, we want to balance the torques on this table to write that F times the height h of each leg is going to be mgd. Therefore, solving for our minimum force F, this is mg, and then substitute this value of d in, which is r cosine 2n over 2 pi over 2n divided by h cosine pi over n. So we just have expressed the least amount of force needed to tip this table over. That's our answer for this problem.